So let's start with the derivative of this messy thing, and then we'll go there. So I'm just probably going to keep quizzing you guys on these all the way through because I don't want you guys to forget these. Okay? Will you have to graph this? No. Okay. Will you have a word problem like this? Possibly, but probably not. Okay. But I want to make sure that you guys still don't totally forget this stuff. Okay. So can I get somebody to be brave and give me the first line for f prime of x, please? Yeah, go ahead, Michael.
Bracket x plus 1.
Yeah. Yeah.
Then bracket 1. Bracket. Bracket x minus 3.
Yeah. Hold on a second. I'm gonna need 2 pages here. That's right. Increase there. Okay, good. So that's the derivative of the first part. Very good. Okay, so thank you. Can I get someone else take the derivative of the second half of the quotient rule, please? Yeah, go ahead.
Minus x plus 1.
Yeah, I'll just call it 1 and then x plus 1.
Isn't there supposed to be a negative 1 on the x minus 3?
No.
Oh,
This one.
sorry.
Here.
Okay, yeah.
Alistair, feeling good about all this? Okay. Alistair, can you be brave? Since you're feeling good about this, that wasn't a trick question. What's a common factor that I can take out of everything? That's good, I'm going to take out also 1/2, just because the fraction can come down below, okay? So that's going to be x plus 1 to the negative 1/2. Always remember when you do these, it's always the negative form that gets reduced, right?
Why did you take out the 1/2?
Because it's otherwise you're going to end up with a fraction in the numerator and it's just messy.
But don't you end up with the fraction?
No, because you're going to divide, right? Remember factoring's dividing. So I'm dividing by 1/2, so that's going to change this to a 2.
Oh, okay.
Just think when you FOIL it back through, right? It's going to go like that. It's okay. Emma, can you be brave, please? And briefly tell me what's left inside the brackets then. Nope.
Right. Okay. So x plus 3.
Yeah, good. Yeah, now there's no spot. I know it's been a while since we've done this, and I'm sorry to put you on the spot like that, but for these here, right, remember it's the positive. When you're factoring out a negative, the positive is left, okay? Yeah, go ahead.
Never mind, I just realized that.
We're good? Okay. I'm going to go up here. If I go up here, is that okay? So that's then going to just turn into x minus 2x is negative x. Negative 3 minus 2 is minus 5. All over 2 x plus 1 to the 1/2. Is x minus 3, and I think that's my final answer. If you ended up with 1/2 x minus 5 over 2, that's probably okay, right? But it's a lot nicer to factor out the 1/2. Go ahead, Brennan.
Why did it turn into 2 in both versions?
What, this part here, you mean?
Or not for their common answer, going from 1/2 to x plus 1 to 2. Is that just the 1 to the bottom?
Yeah, right on, right. Because the 1/2, right on. Because like 1/2 is like 1 divided by 2, so the 2 is just 1 or 2. Yeah, go ahead. Yes.
Why would the 2 plus 1 2?
One more time. I didn't hear you say.
X minus 2.
Oh, sorry. Thank you. Yeah. Thank you. Okay, let's go ahead.
I am a little behind because I had to erase my answer
okay.
and do this again. But you took out the this half
Yes.
over there, and that became 2.
Yes.
Is it okay if we don't do that?
I guess technically it is okay because your root is still going to be the same, but you're
it's
going to have
I'm
negative
so
because you're going to
confused.
have negative 1/2 x minus 5 over 2, and that's just a mess to deal with, right? This is more elegant, if I can say that, for an equation. Okay. Yeah. Yeah, go ahead.
Okay, so if you put the 1/2 at the bottom,
Yes.
then just stop that. And then do you square root that?
Yeah, this square root, yeah, the 1/2 means square root, so that would be like root of x plus 1.
Take out the x minus 3.
No, because the thing is, it has to be factored out, right? So the only thing you can cancel is things that are in factor to both, so things on the left-hand side. All right, I'm gonna do 2 questions from last night, which is number 7 and number 9. I'm actually gonna do number 9 first, and then number 7, just to mess with your minds a little bit, okay? I'm just joking, that's not to mess with your minds, because number 9 is an easier question than number 7, I think, so we'll do it like that. So this is page 197.
It's like every month.
Okay, so we're on page 201, sorry, page 201. Number 9. Okay, the question says, a soup can has volume of 500 centimeters cubed. The top Okay, I love this question. I can't tell you how much I enjoy this question. Like, this question makes me giggle. I was going to say giggle, but giggle isn't a word. It's going to make me giggle with joy. Okay, if that doesn't put a star on your paper, nothing will, okay? This question does, okay? I can guarantee this is going to be on your next test and also on your final exam. Yes. Okay.
Are they supposed to be like dollars?
Cents, that's supposed to be cents.
It's dollars and cents.
Whoa! I got too excited thinking about this question. Sorry, is that better? Sorry about that, thank you. So it's 0.4 cents per centimeter for the bottom, for the top, and 0.2 cents for the side and the bottom. Okay, so maybe for the top what happened was maybe this is one of those soup cans that, you know, like has a thing on it to make it open up. So it's going to be more expensive to make the material on the top than it is on the sides and the bottom. Okay, this could be all sorts of different things that we're going to do. Now the tricky part for this, and the reason I like that, is that our equation is going to be a slight bit more complicated. I'll give you guys a second to write. I see a lot of people in the class still write it. Okay, I'm going to pick on a person at random. Actually, I'll let you guys volunteer. I'm going to play the game though that you have to raise your hand once today. Okay, so now's the time to do it if you can't. What is some given information that we're given here? What's something that we're given? Sorry, go ahead.
Volume.
Volume is equal to what?
500 centimeters.
Good. Anyone know what a centimeter cubed is?
That's the volume, isn't it? Cubes.
Good, but anyone know, I mean, as far as like physics class, there's another unit for it though. Milliliter. Okay. All right, what's the equation for a soup can? What are we going to assume the equation for a soup can is? Yeah, go ahead.
Like the volume?
Volume, yeah.
So pi r squared times height.
Okay, so there's what I know. Okay, I have the volume of the soup can is 500 and I have pi r squared height. Now, if you're fading out of today's class or dreaming about Dota 2, now is the time to stop dreaming. Okay, it's the time to come into reality. All right, because this is the key part. We got to get an equation for surface area, or cost, I guess would be the other one. Cost, we're going to deal with surface area. So it says the top is 4 cents per centimeter squared, or 0.4 cents per centimeter squared. What's the surface area of the top of a can of soup going to be? Pi r squared. Okay, so it's going to be, I'll just write down what I'm going to say. So 0.4 top plus 0.2 side and bottom, right? So it's going to be my cost, which I'm going to call C of x, equals 0.4 pi r squared. Okay, that hopefully we should have no problem with. Okay, so then the next part says 2 cents for the side and the bottom. Let's do with the bottom. What's the equation for the bottom of this can of soup? Pi r squared. So I'm going to say plus 0.2. So this is going to be, I'll just write here underneath to make sure we know. This is your top. This is your bottom. And what's my middle going to be? What's the equation for the middle part of this?
2 pi r h.
2 pi r h? I trust you.
It'd be
Is it 2 pi? Is it 2 pi r h?
Yeah.
I trust you. You guys have the sheets, so I'm not gonna.
Isn't it 0.4 though?
Yeah,
Oh,
I'm gonna simplify things in a second,
okay.
and this is gonna be your side. Okay, now before I continue, I want to make sure this is somewhat clear what happened there. Do we see the difference? So I have to charge some of it at 4 cents, or 0.4 cents, the other part at 0.2 cents. So you can't just plug this into the equation, the simple equation, you need parts of it. Does it make sense how I structured this one so far? Please ask. Great. Okay, so hopefully, so it's 2 cents, you get to the 0.2 cents part.
So what I just did was I, for the surface area here, it's going to be 2 times the base plus the lateral surface. So the base is just the lateral surface plus 2 pi r.
All right, let's neaten this up a little bit. Sorry, Matt, go ahead.
Get the side.
Okay, so the side one was, the equation on that I gave you on the formula sheet was like, that's like your lateral surface. Okay, so it says 2 times the top and the bottom plus your lateral surface, so that's your lateral surface is 2 pi r h. Okay, and if it's the other way to think about it, it's going to be basically your height times your circumference. Like that's what it would be if you were to fold that the can out, would be the height times circumference.
So you're gonna pick 0.2, not 0.4.
Because I told you at the beginning that the top is 0.2, so this is your top, right? It's 0.4, sorry, your top is 0.4, then your bottom's 0.2, so I made a separate part for that and then a separate part for this. So I'm going to do what Chris suggested and neaten this up a little bit. What's 0.4 pi r squared plus 0.2 pi r squared? Chris, go.
0.4 pi r squared.
Close. What's 0.4 plus 0.2?
Oh, sorry. What?
Okay.
Oh,
0.4
I was looking at the other thing on the
Okay.
side. Point 0.6.
Thank you.
Sorry, I wasn't paying attention.
It's okay. It happens. And I will call that. You're right about that second part.
What?
Okay, so this is starting to look good. Okay, I'm loving the way this is looking. What's the next magical step that I need to do? Alistair, go.
Isolate h and volume.
Very good. So I'm going to call h equals, and for the people that weren't here yesterday, the problem is that if you take a look at both of these equations, is that you have an h and you have an r, so you can't take a derivative of something with an h and an r, right? So what I'm going to do is I'm going to isolate the h from this. Some of the other one that I'm only going to have r's in my equation. Yeah, go ahead.
Not if you isolate r.
Yeah, well, no, you can isolate r, but the problem is, like, I have an r squared and I have an r, so it's going to be messy. You'll still get the same answer, right? Like, the answer isn't going to change. But since there's only one h here, it probably makes sense just to sub the h in. Okay? All right, very good, Alistair. Can someone else sub it in for me, please? Somebody new, be brave, please. Be brave, please. Yes, Brendan, go.
Sub in that equation for 500 pi r squared.
Yeah, good. And this is 500 over pi r squared. I'm going to close that door. All right, can somebody be brave? So, if you don't mind, and can you eat up that right hand thing for me? Yep. Very good. Now what she did correctly was pi divided by pi cancels out, right? And then r divided by r squared is r in the denominator. I'm probably going to write this on the next page as c of x equals 0.6 pi r squared plus 200 r to the negative 1. And then I'm going to pick on Luke. You're my favorite basketball fan in this room, no offense to the rest of the basketball team.
Derek's my favorite basketball player.
Thanks, Chris.
I haven't seen any of you play. I haven't seen any of you play, so I don't know who's the best. Can you take the driver of this one, please? Be brave, you can do it.
Take down two.
Yeah.
Goes by
Yeah.
maybe you bring down -1.
Yeah.
Then you go -2.
Okay. And this is similar to the one we did yesterday, right, with the, to solve this, right? So I'm gonna write this as then 0 equals 1.2 pi r minus 200 r to the -2. And I know what you're thinking, Mr. Sadler, this question's impossible, look at all those numbers. You can do it. Ethan, I'm gonna pick on you, in fact. Can you use your excellent algebra skills, and you do have excellent algebra skills, and solve for r, what we do?
So I would think on the other side.
So I think on the other side, I hope you mean this.
Yeah, that's what I mean.
Okay, this is the magical step.
Can I
Chris
do
wants
this?
to do the magical step, all
Wanna do
right,
the magical
go ahead,
step.
Chris.
So technically, 200 r to the -2 is 200 over 2 or r squared,
Yes?
and essentially you can multiply everything by r
Very
squared
good.
to get rid of that messy thing.
Okay, it's gonna be 200 equals 1.2 pi r cubed. 200 over 1.2 pi equals r squared, and I can't do r cubed, sorry. And I can't do that.
That is 3.76.
2.76?
Yep.
7 meters, I'm assuming?
Yep.
Then height was equal to, was it 500 over pi r squared?
Yep.
And that I can't do either. Is this make, I know I'm going through this relatively quickly though, it's just algebra at this point, does this sort of make sense though, like the algebra part, I hope? It's the same example as we did yesterday, right? Okay, except for there's a different setup for it. Can somebody be brave, please? I'm gonna pick on James Campbell, since I respect you so much. James, I have a joke to tell you in a minute. What's 500 divided by pi times 3.76 squared? Oh, James. Thank you, James. Is that right?
I just said random numbers.
No,
Oh,
it's wrong. It's 11.26.
Guys, we're the worst.
It's 11.26.
You guys are the worst. Therefore,
Mr. Sadler, we're not done yet, are we?
I think so. I think we're done.
No, we have to find the minimum cost.
Oh, the minimum cost. Whoops.
We have to put it back into the original equation, right? Because I asked him the question.
Yeah, this could be also why, like for example, a can of Pepsi, they would make it thinner as well, because obviously with the flip top, the top would be more expensive, right? So it makes sense for this one that it's going to be taller than it is wide, because the top is more expensive than the height. Okay. So as far as my cost, C of X, whoops, C of R, I guess that should probably be.
Diamonds don't shine.
All right, James Campbell, now it's your time to
Really
shine, and let them, give them a chance to, when I say James, I mean everyone should be typing into their calculators all the time. And actually technically, now that I realize we have to find cost, we didn't actually really need the height, right? Because X is all we needed to sub in, or R was all we needed to sub in. Hold on a sec, give them a second, please.
No, but it's a question.
Yes,
Don't you put it in the original equation though?
I am.
But
when you
this is the
height-
derivative, isn't it?
No, I use this one here.
Yeah, this is the simplified.
Oh, this is
Oh.
my version, okay.
Yeah, but, so the question was, I didn't ask for height, It just said the minimum cost, so I didn't need it, but I could have said what dimensions would give you the minimum cost, so I did that.
If I put it just back into,
You could have used this messy guy here. Or you could have used this
I
messy
that,
guy
yeah.
here, you could use this one,
Okay.
you could have used whatever one you wanted.
Okay.
I used,
Why did cents come after the number?
It doesn't make any sense.
Especially with
What
you
do you
guys
guys
for
got?
everything that's out there.
79, can we confirm?
I got that too.
79?
Yeah, I got 79.85.
Let's call it cents. Therefore, the minimum cost. Now, I love these questions because it's not just, they're not just standard. All that happened was there's something different happened at the top. I could very easily say, Mr. Sadler's having an ice cream cone. There are diamonds, okay, and the top is gold. Whatever I want to make up, okay, right? It could be anything that would be a pretty close ice cream cone. Let's go with something else then, okay? But the idea is, not everything has to be the same, okay? I'm going to pause in the video, tell my joke, and then I'm going to get started on the next one, okay? Did that help? Was this clear at all? Did this help a little bit? Yes?
I really like this question, Mr.
I
Sadler.
feel like you ordered in this